How is the ohm unit used in Ohm's law? Imagine trying to understand how electricity flows through a wire or a circuit. The key to this understanding lies in a simple but powerful relationship. This is where the ohm, the C unit of resistance, plays a vital role. The ohm symbol is omega. Resistance tells us how much a material opposes the flow of electric current. Think of it like a narrow pipe that makes water flow harder. The narrower the pipe, the more resistance there is. In Ohm's law, resistance measured in ohms helps us connect voltage and current. The law states that voltage equals current times resistance. Mathematically, it looks like this. V equals I times R here. V is the voltage in volts, I is the current in amperes, and R is the resistance in ohms. This means if you know any two of these values, you can find the third. The ohm is defined as the resistance between 2 points of a conductor when a potential difference of 1 volt causes a current of 1 ampere to flow. So, 1 ohm equals 1 volt divided by 1 ampere. This link makes it easy to understand how voltage and current relate through resistance. If resistance increases for the same voltage, the current decreases. Conversely, if resistance drops, more current flows for the same voltage. In practical electrical engineering, knowing the resistance in ohms helps in designing circuits. For example, if you have a resistor with 5 ohms of resistance and you apply 10 volts across it, you can calculate the current flowing through it. Using Ohm's law, you divide 10 volts by 5 ohms, giving you 2 amperes. This simple calculation helps engineers decide which resistors to use in different parts of a circuit. The ohm unit also helps in analyzing complex circuits. When resistors are connected in series or parallel, their combined resistance affects how the circuit behaves. Engineers can calculate total resistance in these arrangements using the ohm as the measurement. This influences how much current flows and what voltage drops occur across each component. Sometimes, resistances are very high or very low. To handle these, engineers use multiples like kiloohms or megaohms. A kiloohm is 1,000 ohms, and a megaohm is 1,000,000 ohms. These units make it easier to work with a wide range of resistances in different applications. So, in summary, the ohm is the fundamental unit that quantifies resistance. It helps us understand and predict how voltage and current interact in electrical circuits. This makes it a cornerstone of circuit theory and a vital tool in electrical engineering. Without the ohm, it would be much harder to analyze, design, and troubleshoot electrical systems.